Okay, this is a quick video introducing excess limiting problems. So far we've just looked at questions where you have a certain amount of reactant and then they assume that you've got enough of the other reactant in order to make the product. So this is when you've got the amounts are given for both reactants, and generally if both reactants are given, then they're not in the mole ratio that you need. So one of them is going to be run out of first, and the other one you'll have some left over, because once you've run out of one of them the reaction will stop. So we call the one that you run out of the limiting reactant, and the one that you have too much of and you've got some left over when the reaction stops, we call it the excess. There's an example in your book about a skateboard. So a skateboard has a deck and 4 wheels. So if you have a certain number of wheels and a certain number of skateboards, how many skateboards can you make? So for every one deck you need 4 wheels. So if you've got 10 wheels, then and 2 decks, so 2 decks would need 4 wheels each, so 8 wheels, and you've got 10, so you've got 2 left over. So the limiting is the other decks. Once you've run out of decks, you can't make any more skateboards, and then you have leftover wheels. So these are the products. So in order to work out how many products you're going to make, you need to work out which one of these is limiting. So it's the wheels, the decks that are limiting. All right, so an example with hydrogen. If you've got hydrogen and oxygen and they're mixed together and they burn, it's a combustion reaction. If you've got a certain mass of hydrogen and a certain mass of oxygen, how much water can you make? So you need to work out which one of these you've got is limiting. So at the moment when you look at mass, 25 grams is less than 300, so you would imagine that the hydrogen is the limiting. But we need to take account of the fact that hydrogen atoms are much smaller than oxygen atoms, so 25 grams of hydrogen atoms might be an awful lot of hydrogen atoms, and it might be in excess. So we need to turn these into moles. So step 1, you need to know the equation. Always write out the equation and put the information underneath it to keep it nice and neat. So for every 1 oxygen molecule has 2 oxygen atoms. Each oxygen atom is going to combine with a hydrogen molecule, the 2 hydrogen atoms, to make a water molecule. So each oxygen atom combines with 2 of these to make, in the end, 2 water molecules. So for every one of those you need 2 of these. So we need to turn these masses into moles, so we're actually comparing the amounts. So you can read these as individual molecules. 1 molecule reacts with 2 molecules, or you can read them as moles. 1 whole mole of these molecules will react with 2 whole moles of these molecules. So we need to turn them into moles, the masses, to take account of the size of the atoms. So now, originally it was looking like the hydrogen was the limiting factor because we have a smaller number. Now, because we've turned them into groups, it's looking like the oxygen is the limiting factor. It's a smaller number than the number of moles of hydrogen. So it looks like we're going to run out of this first. However, we need to take account of the ratio. For every one of those, you need 2 of these. So to work out the limiting factor, there's a few different ways you can do this. When it's a 1 to 2, you can kind of see in your head how to do it. You can halve things or double things and you can work it out in your head. But I'll show you a technique, if these numbers, these ratio numbers, were difficult to see the comparison in your head of which one you're going to run out of first. We'll do step 2. So set up a separate box. So there's a lot of problems with working out the limiting reagent, and there's a problem with this one too. So the problem is when you get to numbers at the end, we can't use them. So set it up as a separate box. That's why I've got a red line around it, so that you keep it away from your normal reaction. So we're going to identify the limiting and excess reactants. So we've got our mole ratios, and currently if you assumed it was a 1-to-1, then this one looks too small, but it's a 1-to-2. So we're going to turn it into as if it was a 1-to-1 reaction by dividing each of our moles by the mole ratio. So now if it was a 1-to-1, so if you divide the 12.5 by 2, you can see that if it was a 1-to-1, that you've only got 6.25 moles when you would really need 9.39 of both in order for them to both react. So you can see that the hydrogen is the limiting factor. We're going to run out of it first. So this technique of dividing the number of moles that you've got by the mole ratio is a quick way of working out the limiting factor. Once you know that hydrogen's the limiting factor, then you use that number to work out how much water you've got. The problem with this little technique, it's easy to do, just divide however many moles you've got by the mole ratio and look at them, and the smallest number's the limiting. It's a good technique, except some people tend to use this number now when they're trying to find out the number of moles of water. They'll go 6.25. You need 2 times that. So it's the same mole ratio, so they'll use the same mole as this, but this is the number of moles that you've got. So once you've worked this out in your separate box, don't use the numbers here anymore in your calculations. Alright, so step 3, using the idea that hydrogen is the one that you're going to run out of first, we use it to work out the amount of water. So you're just doing your mole ratios, put what you want on the top and what you've got. So it's the same number of moles. So because you've got 12.5, you've got 12.5 moles. And then when you get to this point, you know the number of moles of water. Just make sure you fully answered the question. So the question actually asks you what mass you make. So now that you know that you've got this many moles, then work out the mass. So just always check. Sometimes when people get to the moles, they think they've finished a question. Just reread the question and make sure you've finished.